All right, here we go. So graphing the rest of these periodic functions, and now um, really very highly recommended. Actually, I'd recommend this for all the videos, but in particular for this one as well. That you go through and try them on your own first, and so when it's just notes that you're just filling in, that I'd recommend you go to the book first, see if we can develop that skill of being able to learn from the text. Um, and then use these videos really as a tool to just to supplement that. To hey, I was kind of confused in this topic. Here, I'll try this. And so, but this one in particular, I think that if you just watch these, it will not be nearly as beneficial to you as if you try them first, pause the video, try them, and then come back and see how you did. I think that's going to be definitely in your best favor. So right now, I would highly recommend you pause and then come on back. Um, so, uh, so welcome back, and we're going to sketch the graphs of y equals negative f of 2 times x. And notice that there's two things going on here, that there's both the input is being multiplied by 2, so it's going to shrink our period to, again, the same graph, so our period of 5 is going to come down to 2.5. And we're also going to then multiply our final output by a negative 1. So this is going to shrink horizontally. Actually, let me change that to red. I'm going to graph this kind of in two pieces, and I would recommend you, at least at the beginning, that you're thinking through that kind of the same way. So my first thing is I'm going to shrink horizontally. And I'll graph that one in red. And then after I shrink it horizontally, then I'm going to multiply my output by -1, which really is reflecting over the over the x-axis. My y values will switch, so it gets reflected over the x-axis. And so our final graph is going to be the one in blue, but I'm going to do two of them kind of to build it out piece by piece. So first, shrinking horizontally means I take all my x values, and if they're all happening twice as soon, and so what happened at 1/2 or 1 now happens at 1/2. What happened at 1 now happens, or at 2 now happens at 1. All my x values are cut in half. So remember 1 over c, and our c value there is 2. So everything's happening at half the previous x value. So where it was at 2, or so at 4, now it's at 2. Where it was at 3, it's now at 1.5. And so let's keep on cutting these all in half here. So that's 6. Now it's happening at 3. Goes a half. All right. There's just the right side of the function. And rather than waiting for me, I mean, certainly feel free to just skip ahead in the video. And save yourself the time. But again, hopefully you did pause and are trying this on your own, because I think that's going to be the most beneficial for you. And so what I've did here is I just tried to take my x values, cut them in half, and graph my output. Now that's the first step. So we have now shrunk it horizontally. And next we're going to reflect it over the x-axis. And so let me actually make it a little bit bigger of a pen just to kind of say the red's not our final answer. We're trying to get to the reflection of that over the x-axis. So everything's where it was a positive y value is now a negative y value. Where it was 0, it remains 0. But the whole graph is getting flipped upside down. Whole graph is getting flipped upside down. So we end up with this graph right here. Now notice that the little plateaus, which were up on top, are now down at the bottom of the graph. That the little spikes that were at the bottom, they're now at the top. This whole thing's been flipped top to bottom from the original graph that the the period has been shrunk in half, and there we go. Hope that one helped out. So next one we've got is going to be again, I'd pause and then come back to this, but breaking it up into its two pieces, and we're going to first take the absolute value of this, meaning that our outputs are all going to be made positive. Positive output. And so every part on the graph first is going to just become positive. If it's already positive, then it remains positive. If it's negative, then it's made positive. And so here's kind of how I would think through this is, well, there's my first step, and I would start in the inner part of the parentheses and work my way in. I mean, if you are more comfortable doing the outside first, as long as you're being careful with it, then that's perfectly acceptable. So we got our positive output, and now all those outputs we're going to double, where we're going to multiply by 2. So now stretch by factor of c, and our c value is 2. So where it's at 0, it remains at 0, and where it's at 1, it's going to jump up to 2, because 1 times 2 is 2. 0 stays at 0, and there we are. Now again, you don't need to watch me do this. If you just want to check your result and then come back if it's wrong, then I mean, by all means, go forward in the video. But there's our result. So our plateaus, which were already positive, stay positive, but those spikes at the bottom, first the absolute value made them positive, and then we multiplied it by 2 and everything doubled in height. All right, let me go ahead and pause the video. I feel like this is getting kind of long, but come back and do the next two here at the end.